Okay, so the next section of this chapter talks about organic chemistry in terms of what makes carbon unique. So, organic chemistry, when you hear that term, sometimes it can be a little intimidating. All it really means is the study of carbon compounds, and usually it is also talking about carbon compounds in conjunction with oxygen. Very commonly, the carbon compounds that we are going to study in this class have to do or have carbon partnered with either oxygen, hydrogen, or nitrogen, which you'll also notice are kind of the four most common elements in biology, right? So that is a reason why, because our concept of biology, at least on this planet, right, is based on carbon, and carbon's most common partners are oxygen, hydrogen, and nitrogen. We also just learned that carbon is a special type of atom that can make the maximum that we know of, which is 4 stable covalent bonds at the same time. So we call this tetravalence. It means that there's 4 valence electrons. So it could kind of add 2 to get to 8 or give up to get down to 0. But either way, we're adding or taking away 4 electrons, so we're making a maximum of 4 bonds. So this gives carbon a lot of variety, a lot of different shapes that it can take, a lot of different partners it can pair with, and we'll see some of that diversity here next. So these are some of the examples of what tetravalence can do in terms of shapes of molecules. So we can have kind of basic shapes where we just have one coming off from each side of a carbon, and that's it. Or we can start to arrange things into rings or chains of rings. And this is where the kind of variety that of shapes that carbon can make is really kind of what makes it the backbone of the life forms that we have. Okay, so when you only have carbon and hydrogen bonds, we call this the non-polar covalent bonds because they do actually share really equally. And when you see a lot of these with just the carbons and hydrogens, these are really stable, and so they actually store a lot of energy in them. So we call these hydrocarbons, and we see hydrocarbons. I want you to think high energy storage because they're holding a lot of energy in those really stable bonds.